Okay, so today actually we stopped at like just programming point, right? Am I audible?
Yes, sir.
So we just stopped yesterday like programming point. So today we will try to test that program. So I will just connect this Node MCU here. Okay, so I cannot connect this way. Basically, I want A naught now. Okay, so A naught, and so can you tell me? Let's project. Let me project my screen. So, for instance, if I have now, like this is a raindrop sensor, you assume. So this box, maybe we'll put it in some shapes. So you assume this is a okay, and usually this raindrop sensor will have plus 5 volts, and another end will be connected to one variable port. Okay, so these are the two inputs. Okay, so now we have that node MCU, right? In the node MCU, I have analog input pin, that is A0. So this is basically node MCU. So I'll be having this plus 5 volts and one ground pin. So I want to measure the variation from the raindrop sensor. Okay. So can you suggest me how I can connect this? How I can connect this? So we have various points, right? Maybe if I assume this as point A, this is point B, this is point C. Okay. So can you just map this to? So this is, I can say this is A, B, C, D, E, F. So can you tell me like where I have to connect A in the raindrop sensor to what point in the node MCU? In that way, can you just try to map? Please think and I'll give you 2 minutes of time. So can you all think about it? Hello, everybody is there in the call? So I'll ask each one of you, please, could you please tell me like how to, maybe can you try in pen and paper and put the screenshot in the classroom link? That we will do, okay? So we'll do that exercise. So we have that classroom, right? I'll just open that. I'll type a question, so we'll try that, okay? Did you all understand the question? Understood the question? Hello, yes, no? Students, are you there in the call?
Can you repeat the question, sir?
Yes, now we have this raindrop sensor. Like we have A, B, C. These are all the points. Okay, this in the node MCU. Now we have to interface this raindrop sensor to this node MCU. Okay, so in the node MCU we have analog input pin D, E, F. So now I have to interface this raindrop sensor to this node MCU. So how we can? So I just want connection like A of this point where I can connect. Should I connect to D, E, F? B where I have to connect, C where I have to connect. I want that kind of maybe like no need of circuitry. You can just mention that like something like A to F, B to E, something like that. You can put it in chat also. Quickly think, because yesterday I had clearly mentioned how to do that. A to E. I mean, together you can mention all the points A, B, C, where I have to connect A, B, C points in D, E, F. That mapping you have to tell me. Yes, we got many answers. So Nalina is saying A to D. So let's put all the possible answers what we received from the students. Let me just type it here. One answer what we got is A to D. That is, we have to connect this to D. Okay. B to E. C to, yeah, this is the one answer what we got. This is from Nalina. So what other answer we got? So Rakshita is saying A to E, B to D, and C to F. Let me take one more answer and I will just try to understand. Uh, so Meghana is again saying like A to E, B to D, and C to F. Same answer. So actually, see, yesterday I was saying, so if I give something like plus 5 volts here, and I will have some variable resistor. And again here one more resistor. So if I consider this as the raindrop sensor, so whenever I vary this, so whenever like when there is no rain, this will be open circuit. Here I will get 0 volts. as we get some rain, we will be getting some voltage here, right? So basically, I have to measure voltage across these points, right? This and this, across this, between this and ground. So, so actually, if I want to measure B and C, so B has to be connected to D, right? So maybe like we'll change the color. So this B has to be connected to D, and obviously, like here, if I want to connect D, so this will be like, if I want to measure across this, C has to be with respect to ground only, right? So ground is this, and A to here. So in this way. In this way, we have to connect. Clear, everyone? So now, let's. So I don't have pot. I don't have resistor. So we'll assume one thing as a raindrop, and we will change other resistor. Okay. So I will just make a setup. I will protect that. So I have this 5.6K. Okay. Maybe first experiment, what we will do, we will just connect this plus 5 volts directly to the A naught. Okay, we will see what will happen. So I have wires. So just let me open that. Both the end same I want that. Here. So we have this. What I will do, are you able to see the pin numbers? It's not clear actually. Yeah, you can see we have A naught here, right? At this point, A naught. So what we will do, I will connect one end of this. So from A naught, let me just connect this to uh, plus 5 volts. So you can see here 3 volts. Sorry, we have 3 volts. This is actually like not 5 volts. Arduino usually it will be 5 volts. Here it is 3 volts. So yesterday's computation also we have to change actually. Okay, so because it's not 5 volts, right? So we have calculated with respect to 5 volts, but we have to calculate with respect to 3 volts. So this 3 volts, there is one 3 volt pin also. Can you see your? I think you are seeing mirrored version, right? So but I can show you. This is the 3 volt pin. Okay, so it's a 3 volt. You can see it's a mirror version you are seeing. Um, so let me just connect that to 3 volt. This is the pin. Yeah. So we will just remove the uh, other Wi-Fi coding, all this stuff. So first we will just demonstrate the ADC part. Okay. we'll plan to demonstrate the ADC part. Let me open the Node MCU. Let me open coding part. Okay. Okay. So I'll make it as a ADC demo .ini. Okay. Hash include Wi-Fi because this we are using ESP8266 Wi-Fi board, right? So let it be these parts. This also it will not trouble us basically. So Wi-Fi client also let it be there. ADC sensor pin we have made it A0. So let it connect to Wi-Fi. No, let's disconnect Wi-Fi. Okay? So we'll not focus on this. So we'll just serial dot begin. We'll not use Wi-Fi now. First, we will not constrain it. Okay, whatever we get it. So I'll just print that. So let me remove these parts also. Whatever I get, I have to just print it. Okay, so we'll not put this rain sensor condition also. Every 3 seconds, let me put. Okay, so if I want to make it 3 seconds, what should be the value here? What value should I write? So every 3 seconds I need to read. What value should I write here in the delay?
3000.
Yeah, because it's in millisecond, right? So that's where like, so this is actually reading part. The ADC. So now I have to print every 3 seconds. I have to print like I have to print ADC value is whatever the value I get, for instance, 1024, 2048, whatever it may be. So how should I print? I mean, if I want to print like this, so what should I do? how to print in this way. If I want to print in this way, how to print? Serial dot serial dot what function do I need to use? What is the function we can use for printing? Print ln or print ln or print.
Print ln.
Okay. Print ln if I do, see the ADC value is, and this value we will get in the next line, right? So we have to use print. So this actually whatever we have saved that is in the wrong format. It should be INO. Okay, dot INO. That's where it was wrongly. So now I have to print the ADC value. So what variable do I need to put it here? Serial dot print. Serial dot print. What variable do I need to print? So where to which variable we are reading the analog value? So analog read I'm assigning to serial sense value, right? So that value I need to print. So here whether it is a print or print ln, because next value whatever I read that should be in next line. So here I will be writing print ln. So till here are you clear? Everybody clear till here? Yes or no? So this is while loop, right? It will be continuously happening. Are you clear till here?
Yes.
Let me open Arduino and Arduino INO. So file, open. So this is the code. So just check, we need to check which board is selected. So which board we need to select here? So if I want to run ESP, so which board do I need to select? Which board? Last class we had discussed, right? Which board do I need to select? Which board do I need to select? Do you remember what we have discussed? Where you were, like when we were discussing. It is actually Node MCU 1.0. So port, make it COM8, not COM8 actually. Let me connect it. So I have added now, so you can see along with COM8, COM3, right? So let me compile this. Still getting compiled. So it is showing some of the errors. Not error, actually, it's a warning. So let's program upload this. So yeah, so it's programmed. So now you have to see serial monitor. Can you see it's showing 1024 everywhere. So any reason why it's 1024 everywhere? Can someone justify this why it's 1024? Can anyone tell me why it's 1024? Quickly. Am I audible first of all? Am I not audible to anyone?
Audible, sir.
Yeah. So can you see the screen? Is it visible?
Yes, sir.
What you're seeing? ADC value. What value of ADC you're seeing?
1024.
Yeah. Can anyone justify why it is 1024?
Sir, maybe 10 digital outputs in truth table will get 1024 number of possibilities.
So yesterday we discussed one concept, right? So what is the resolution of ADC? What is the resolution of ADC? How many bits? Resolution means how many bits? How many bits ADC we have in the ESP?
12 bits.
It's a 10 bit. So using 10 bit, what is the maximum value we can represent using 10 bit?
1024.
Maximum is 1024. So maximum is 1024 means actually my actually like ESP has like it's a 3 volts device. Okay, so 3 volts means 1024. 0 volts, 0, right? So now in the hardware, how I have connected? What is my connection? How I connected? How my node MCU is connected in the hardware? Where I have connected ADC pin? This A0 pin where I have connected in the hardware. So you can see this camera also, right? Are you able to see this camera also?
Yes, sir.
So I have connected how it is connected. So this pin, whether it's visible. This is A0 pin. Okay, so this is A0 pin. I have connected to this 3 volts pin. So this is connected to maximum. Okay, so 3 volts pin I have connected. So this ADC I have connected from ADC input I have connected to 3 volts. That's where we are getting 1024. Okay, so now what I will do, I will change this connection. Okay, so 3 volts I will change it to, I have ground. Okay, I have ground. I will change it to this ground. So what value do you expect now? I connected that ADC input to ground now. So what value do you expect? Ground means how much voltage?
0 volts.
Yes. So in the digital value, how much? So 3 volts is 1024. So for 0 volts, what value do you expect?
Zeros.
Yes. So let's see that serial port. Where I connected back to 3 volts. Now I will connect to 0 volts. You can see it's a small value. That's an error actually. Okay. So because there will be some issue with respect to ground, always it will not be clean. So this ground is connected to. So this my ESP is connected via my laptop, right? My laptop grounding might not be correct. So because like your home grounding depends on home grounding. So my house grounding might not be exactly 0 volts. Okay. So that's where we are getting some 5. It's almost 0, right? It's the lowest value. So now let me make one small setup. So first you need to calculate and tell me what value do you expect, and let's see whether the same value we get. So this is 5 point, let me just zoom in. So this is 5.6 K resistor, okay, 5.6 K resistor. I'm connecting here. And I have another 150 K resistor. No need 150. This is 5.6 K and somewhere around 6.8 K resistor I have another. Give me a second. I'll just so this is 6.8K. Okay. So I have connected in series. So 5.6K and 6.8K. So I'll just show you the configuration. So I have connected. This is 5.6K. And here 6.8K. Now what I will do, this 5.6K I will connect to 5 volts. Okay, so I'll connect this, not 5 volts, sorry, this ESP 3 volts. I always get confused. This is 3 volts. I'm connected here with the 3 volts. Let me take pin. So from here, I connected that to 3 volts. Okay. And I will connect this across 6.8K. I will just connect to ground. Okay. The 6.8K I will connect to ground. So this is the thing. So this I will connect to ground. Okay. Ah. So if I want to measure the voltage across 6.8K, how do I connect? So you assume, so we have points, this is A, B, and this is C. So which point should I connect if I want to measure voltage across 6.8K? So which point should I connect to the A naught? So I want to measure voltage across this 6.8K. So which point should I connect to A naught?
B.
Yes, I need to connect B, right? So let me connect another pin here. B to, okay, let me just before connecting to B. So can you calculate? So this is 3 volts. So what number do you expect? So we have 6.8K, 5.6K. So what voltage do you expect at the peak? Can someone calculate and tell me what voltage do you expect at B?
1.64 volts.
1.64. How did you calculate?
6.8 into 3 by 12.4.
6.8 into 3
3.
divided by 12.4. Good. So in terms of, see, for 3 volts, we get 1024. So in the same way, can you tell me what value do you expect for 1.64 volts?
Five 59.786.
But we get digital, right? 559. There will be error, but it is because like your resistor also might not be approximate. So you should get value between 500 and 600, somewhere in that range, right? So let's see what exactly we get. And there will be quantization error also. So just let me connect this to A0. And open that serial monitor. See, it's almost 576, but how much you calculated? 559, around 560. You got it initially, but there will be some error. If you have seen 560, you are getting 576. If you had seen initially, ground itself was around 7, right? Ground, you are getting for ground, it was 7. There is a uplift of voltage. So clipping this say that's actually because of your grounding issue of your host. So instead of 559, we are getting 576. That's correct only, right? 559 plus 7. It's 566, but still like around 10 difference will be there. No issues because like quantization errors, right? Everybody clear?
Yes, sir.
So actually what happens, see, we'll take the example of raindrop sensor itself. Okay, so whenever there is no rain, whenever there is no rain, what will happen? So this particular part will be open, right? 6.8K will be removed. So we'll see what will happen if I remove that 6.8. So this is 6.8K down part. So I'll just initially I'll present this. So okay. So usually like what we'll do. We'll be adding raindrop sensor here, okay, usually, or here, but usually if you add here it will be more efficient because like we'll be measuring across this, right? So we can easily identify that, okay, this across measuring across spots. So here we can calibrate easily. So you assume 5.6K as a raindrop sensor. Let me open that monitor, serial monitor. You're getting 576. Now I will remove this resistor. It means there is no rain. Okay, so it's fully open. So you can see 0, right? 5 volts, 5 value 5. So it means there is no rain, right? You're seeing that? Hello? You are with me?
Yes.
Okay. Now what I will do, this is very small resistance. It's 150 ohms, okay? Here that was a kilo ohm. It's 150 ohm, very small resistance. Okay. So I will connect this. It means like slightly raining. It's slightly raining. Did not connect properly. Whenever there is slightly raining, it is more resistance, right? So I mean, slightly resistance should be removed. This is 5.6K, 150 ohm. Slightly raining means, let me put something like some 500K or something like that if I have. I don't know whether that means resistance. That's because like high resistance usually it will be costlier. Okay. Yeah, I have 330 kilo ohms. Okay. 330 kilo ohms. This is 330 kilo ohm. Can you see? It's around 19 or 40 it is, right? 40, 27. Is it varying continuously? Yeah, 27. It's accurate. So it's around 27. Slightly raining. It increased, right? So this is 330 kilo ohm. What I have done. So now rain increased, you are saying. So when rain increased, more and more water drop will accumulate on that plate. So when the more accumulation happens, resistance will decrease, right? Resistance will decrease. So now I have 8.2 kilo ohms. So I will, okay. What I will do, I will not remove this. I'll put it in parallel, okay. So now it actually increased, rain increased. So I have added like this. So can you tell me what is the actual voltage you are measuring there? So let me check how many are your like really remember your network basics. So I have put like this 330 kilo ohm, and I have another 5.6 kilo ohm, and here 6.8 kilo ohm. This is connected to 3 volts. So what voltage do we measure here in this scenario? Quickly, can someone calculate this? Are you calculating? Yes or no?
Yes, sir. 1.65. Sorry.
Okay, what is the effective resistance here?
12.306 kilo ohms.
How to calculate it?
Sir, first 5.6 kilo ohms and 330 kilo ohms are in parallel. We have 5.6 into 330 divided by 5.6 plus 330.
Yes. So this is the effective resistance. Then what you have to do is, if I consider R, then R into 6.8 into 3 divided by 6.8 plus R, right? So this will be effective voltage, right?
Yes, sir.
So how much voltage did you get?
1.657 volts.
1.655.
57 volts.
So what digit do you expect here?
2.
No, not 2, right? So 3 volts is 1024. 1.655 is how much? So cross multiplication, 1024 into 1.65553. How much?
$565.83.
568 around, right? So we'll see what value. 483. I mean, I think 5.6. It's not 5.6K. It's different. Slightly resistance is different. That's where actually we are getting that. Okay. Fine. So now actually like what we have to do is we have to control this LED. Okay. So what you can do, we have internal LED, right? So I'll give you 10 minutes of time. So you have to do this exercise. So we have that value, right? So ESP value. So now what you have to do, so if that count, okay, maybe okay, 0 volts. If that count is greater than 20, that is like slight voltage is there. Okay, analog value is greater than 20, then turn on LED. Okay, inbuilt LED, which is connected to 2. Else, turn off. That is no rain detected. So if that is greater than 20, turn on LED. Else, turn off LED. Can you try this? I'll give you 10 minutes of time. It's 10, 20, 20 15. So by 2025, you try to complete this. I'll create a classroom question also. Let's see how many of you submitted. Everybody got the question? Yes or no? Everybody understood the question? Do I need to repeat it? So I'll post this reference code what we have. So rain sensor implementation. So if the analog value is greater than 20, then turn on LED, else turn off. Okay, so I'll add the reference code also. Please download this and update that code and again upload it back. Okay, so I'll share the link also again if anybody does not have that. I'll post it in the chat. I'll give you 10 minutes of time. Quickly do it. Everybody understood the question? How many of you understood the question? Can you raise your hand? Only one? 2. What about others? They did not understand the question. Should I explain again?
Yes, sir.
Okay. So we have this code, right? ADC code, what we have written. So you saw whenever the resistance is too high, that is no rain is present. So then we get 0 value or like 4, 5 values, right? So less than 20. So whenever the rain is not present, the values are less than 20, whatever the value we are getting less than 20, then we should not turn on the LED. So whenever we change the resistance, I showed you demo. So whenever we reduce the resistance, it means some raindrops are present on the rain sensor. So whenever that condition occurs, your value goes high because resistance is less. Your value goes high. In that scenario, you have to turn on the LED. So for that, I have given this reference code. I have uploaded in the classroom this reference code. So you have this rain sensor value is the value, whatever I am mentioning. So you have to put one just if condition and control that LED too. So we have that LED pin, right? You have to control that LED pin. Now, did you get the question? Now, how many of you understood the question? What about others? You all there in the call? Okay. Can you just raise your hand? How many of you are there in the call? What about other 14 people? Where are they? Let me launch one poll. It will be just 20-second poll. I'll just talk within 20 seconds. Quickly answer it. So it's basically 128 bytes. Okay. So please quickly write a code and upload in the classroom. I'll give you 5 minutes. Those who really interested, understood the concept, please try it. I will not lose anything if you're there in the call or you're not there in the call. It's your wish.
Sir, unable to open the document.
Classroom link you are not able to open, is it?
No, sir, reference code not able to open.
That is INI format. So INMO format. You have to download and open with the text notepad. It's in Drive, right? So directly it will not open. So download it, then open it in the notepad. Still, if you are facing issue, let me know. I'll put it in text itself.
Okay. So still not possible to open.
Okay, let me just post that as a text. So I updated. You can just as a text itself, you can copy. Yes, everybody completed that assignment? Did you all submit it? Yes, how we have submitted. You just check that answer. So I'll copy that code. Good. I mean, it looks correct. Let's try it on hardware. So here we are reading the ADC value. So here one syntax error is there. So correct it. So this bracket has to go here. Okay. So if rain sense value is greater than 20, rain is detected and LED pin we have to set it as high. Else rain is not detected, digital write LED pin low. That's a simple logic what we have to write. Okay. So now let me save it. Okay. So now we just compile it. There is invalid error. So it should be serial, yes, capital. Okay. Serial.println. So here also it should be capital. Let's compile this. Still we have some error. So this capital S is capital. So again, this also you have to modify. So we should be careful about case, what case you're using, lower case or upper case. Okay. So this is compiled. Now let me run this code. So actually, last class also we had discussed it's reverse way. Okay. So if you make it high, it will be low. The anode or cathode, which is connected to the thing, right? It's based on that we have to try. So you have to wait. You have to make reverse way. So when rain is detected, it should be low. Else it is high. Okay. So again, we'll compile it. It's a reverse actually. Inbuilt LED is reverse, or else like you can externally if you want to connect, so you can actually correct it. Yes. Now you can see, you all can see my camera also, right? Hello.
Yes, sir.
Yeah. So you can see this LED, right? So whatever the resistor condition I had, like previously I had added, bring it nearby. Resistor condition I had added, so it was actually like giving rain detected condition, right? So because of that, actually, like you are seeing this LED on, right? So now just let me remove these two resistors, which is open condition. See, LED went off because rain is not detected. So this way, actually, like you can detect the rain basically. Okay. So let me just connect it back. Some amount of rain detected case. Okay. So I connected this. See, now again it is glowing. So rain detected, right? So maybe based on this, we can. So actually, like what we had to do. So this we have to put it into cloud, and those data, based on that data, you have to irrigate the land. So do you all remember what was our ultimate goal? For what project we had come to this point? Based on what discussion we had come to this point, like rain detection sensor? What was our actual project? Do you remember from which point we came to here yesterday? What project we were discussing? Why we wanted this rain detection sensor thing? Do you all remember? So do you all remember this project? What we were discussing initially? Weather prediction. So first
Yes.
was rain data, right? Rain data. So we have to control the watering of land. So similarly, we actually like saw one rain sensor. So we were actually trying to build this, right? So this agriculture project. So we completed the rain sensor experimentation. This is rain sensor. So next I asked to check the moisture and humidity. So this we will actually connect to the A0 analog input. So next I asked you to find the moisture level. So it's your task. Can you just so usually like whenever you are doing project, nobody will be there to suggest you, right, which sensor you have to use. So now you have to, it's your task. You can use net, book, whatever it may be. Find some moisture sensor. I'll give you 3 minutes. So can you explore on moisture sensor? I'll give you 2 minutes. Suggest me some part number for the moisture sensor. So just let me, did anyone explore? Can explain what you have found out? So Deepa is saying tensometric and volumetric are two primary sensor types that measure soil moisture, right? So I'll just present that a little bit about. So it's actually like working principle wise, if you have understood the rain sensor, it's actually same as that, okay? So let me just present that. Yeah. So the principle, working principle is same as your rain sensor. Okay. So if you see, this is the usual soil moisture sensor. Okay. So can you tell me? So in the if you had seen rain sensor, it was like this. You had this kind of structure. So this kind of structure we had. So this is basically one nickel coating. So we had these gaps, right? So whenever raindrops, for instance, raindrops comes and sits here, so it will build some, it will reduce the resistance, right? So it will reduce the resistance, and based on that, we were identifying the whether rain is detected or not. So this is rain sensor. So here, can you tell me how our resistance actually might work? Any brief idea by seeing the structure? So this is actually metal stripes, right? Metal stripes. So usually what happens whenever there is more moisture, right? So if you consider one pot, okay. So let me, this will be like for soil moisture, right? So this probe will be put like this. It is positive, this is negative. So initially you pour water, so you assume soil moisture is everywhere, okay, when you pour the water. So how it will deplete? Is it from this will deplete from bottom to up or up to down? How it will deplete?
Up to down.
So it will be depleting in this way, right? This way. So it will be keep on decreasing, right? So at the end, actually, like moisture might be there in the bottom, but up it won't be there. So whenever it's completely moisture, so the conductivity will be there here everywhere, right? More conductivity, right? Everywhere it will be conductivity. So as water start depleting, so it will be there only here. So whether resistance will decrease or increase. When there is no moisture at all, so it will be completely isolated. So it's same as your rain sensor case itself, right? Right? Yes or no?
Yes, sir.
It's same as your rain sensor case. So this is how actually like we identify. I mean, like code wise, it's same for both. It will work. Whatever the rain sensor, it's like whether water is present or not. In the same way, we can actually identify. Okay. So now we'll go back to this slide. We also find moisture sensor. So what we have to do in the cloud, we have to, if or in the ESP itself, if that rain sensor data is present, then you can actually like measure the. So one more question. Whether rain sensor and moisture sensor, both do I need to compare, or either one of that if I compare that is sufficient? Do I need both the sensor or one sensor is sufficient? Both are required or one is sufficient?
One is sufficient.
Either one of that is sufficient, right? So I mean, rain sensor we can include. This is actually like this is optional. So based on rain, right? So maybe we can predict something like, so today if it is rain, so maybe like entire sensor system itself I can just, because like you can have some kind of what to say, this may be required for your some predictions, like so some artificial intelligence algorithm if you want to implement. So there will be one of the conditions that like, so see, whatever the ESP you are deploying, that will be in field, right? So should it be on all the time, or it can be like sometime it will be on, or like sometimes it will be off, something like that you can. Should it be on all the time? Because power is very important. You cannot supply this power through battery and all, right? Each time you cannot keep on changing this because this is in field. So if you want to apply certain artificial intelligence algorithm, something like if there is a rain, then some prediction like I'm not going to irrigate for 3-4 days. So because what will happen, right? So if rain occurs, so the moisture level is going to be long, right, compared to your watering. Do you agree with that? So if you just irrigate it, how the moisture level of soil will be different than how it rains. Rains, it's like rain. It will rain for heavy. It will rain for a long time, and based on the rain data, you can measure like how long you need not irrigate it, right? So you may have to do some prediction algorithm, because if you want to irrigate, that is not straight away you are irrigating. So you may have to store some. So this water storage. So you might be like getting this water from somewhere in somewhere from the lake or so on. So you need not store this water, right? So you need not store this water for a long time. So or like so this connectivity you can remove for some time, because like since already it rained, so you need not store. So the storage level identification. So this is actually both will be required if you're going for some AI algorithm, artificial intelligence predictions. Based on that, like if rain comes, so if the soil moisture level something is there, because these are all the parameters, right? So these are all like just parameter for your comparison. Do you agree with this? Because based on rain, you can have something like some like what do you say, covering control and all, like for instance factory kind of systems will be there, where factory kind of agriculture will be there, where you may have to cover certain plants with automatic coverage systems and all whenever it rains. So that control, and if you want to do, so you will be like you may have to control this. So one important thing, another important thing is like driving this pump whenever moisture level. So instead of LED, you have to drive the pump. So actually my next question is, if I want to drive this pump, if I want to drive this pump, so is it just plus 3 volt is sufficient? So I have a pump, you assume that is an inductive load. Okay, whenever moisture level falls, I want to drive this pump through node MCU. Okay, so my node MCU output is just plus 3 volts. How to drive this pump? Okay, so this is actually my question. Think about it. We'll have a short break. Okay, so maybe we will come back at 11:25. Okay, so meanwhile you think. So if I want to drive this pump, how I can drive this pump? So you have load. So how to drive this? Okay, think about it, and we'll meet at 11:25. Okay, thank you. let's get started. Can you all hear me? Can you all hear me?
Yes, sir.
Yeah. So how to drive a pump? Can someone help me here? Anybody searched how to do it? How to drive a pump? Yes. In general, how do you drive a pump or motor? Any inductive law? Please, you should tell this because you are all easy students. So I'm asking some simple questions. At least you can have an attempt on this. How do you drive a pump? So let me simplify this question further, or like we'll take a different page. So this is DC pump. Okay. So this requires plus 5 volts. But in our node MCU, what is the voltage we have? In the node MCU, what is the voltage output maximum we can have? So what is the voltage output do we have from the node MCU? In ADC example, we have seen, right? What voltage we have maximum? It's 3 volts. Good. It's 3 volts. But we want 5 volt now. Any idea how we can do it? Any idea? We have these quad level shifters. Or quad means 4 actually. In general, it is a level shifter. Which will convert these 3 volts into 5 volts. Okay. We will be usually having this level shifter. So I will connect these 3 volts to this level shifter. And now we have 5 volts. Next, if I turn on and if I want to turn on and turn off this pump, whether that 3 volts pin we have in the node MCU, right? Do I have control over this pin? Can I turn off and turn on this? Like, do I have, like, even program, do I have control for this? Do I have control on plus 5 volt pin? Do I have control on this plus 5 volt pin? Or sorry, plus 3 volts pin. Do I have control on that? Can I control in program? Can I write something and control these pins? Yes or no? You can just think and, like, yes, no, don't know. Just can you all type that in chat? Yes, no, don't know. Three option I am giving. So can you all type? Whoever in the call, please type. Can I have? Do I have control on? This is the question. I have written that question also. If it is like font is too low, I can increase this font. Okay. Now it should be visible to everyone. So yes, no, or don't know. Can you all type your answer? First of all, am I audible?
Yes, sir.
Yeah. So Deepa is saying no. Kavya is also saying no. Any other answer? Yes, many are saying it's no, because this is a power pin. We don't have control on this pin. So we have control on GPIO pin, digital pins, right? GPIO pins. But this requires current. It's a heavy, I mean, it's an inductive load, right? It requires heavy current. So that current has to be driven from power source only. This GPIO pins does not have current capability driving this load, right? So here it will be again 3 volts. I can put level shifter, but it does not have current driving capability. So what can I do here? Anybody? So I mean, here instead of level shifter, you can use DC to DC converter also. This is most recommended. Okay, DC to DC converter. Okay, so now how I can do? I mean, any idea? We had actually discussed some time back. Can you think of it? So usually what we do is basically we go for MOSFETs or transistors. I had told you also, right? This one, how we control actually like your home automation thing. It's same because it's a 230 volts. You cannot control, right? So directly the 230 volts will be connected to this 230 volts, and here it's just 5 volts level shifter if you independently want to operate, or external pins also you can connect. Okay, so here this GPIO you can connect. Okay, so now whenever you want, like your moisture sensor level says that moisture is less or rain did not appear for 2-3 days, then you will just drive this. So pump will be on, water will be irrigated. In this way we can control. Any questions? So we saw about pump also. So similar way, to monitor the quality of fruit, to detect the animals, what kind of sensor we can use? For detecting the animal, to monitor the quality of foods, what sensors we can use? We can go for cameras. Okay, we can actually like you will be having camera breakout board, camera interface. So I will not go in detail in depth here because we have to discuss on I2C and all. So here it will be I2C, SPI, all these protocols will be there. Okay. Maybe briefly we can discuss. So because the data will be transmitted using I2C, SPI or UART. maybe I would like to, I had discussed this on your basic embedded also. I would like to refresh this, okay, because that is a very important protocol which will be like on this, if you know. So whenever we go to embedded as an embedded engineer, right? So for instance, in the industry, if you are going as an embedded engineer, embedded system engineer, maybe you can note it down. These are all the skill set what usually embedded system engineer we ask in the, I mean, during interview also. Okay, so one thing we expect basic C, embedded C. Okay. Second, fundamental of any one microcontroller, any, okay, any microcontroller. It can be 8051, 8086 microprocessor, anything, but you should be perfect in that. Okay, you should know in and out of that. And interface. As a fresher, if you know if you are I2C, SPA. So as a fresher, if you know these three things at least, that is 200% more sufficient to get into embedded system engineering. But if you are trying for VLSI engineer, then you should know fundamental of digital electronics, at least one language, Verilog, VHDL, or system Verilog. So these are the general flow. What in the VLSI, okay, Verilog, VLSI, and like some basic of analog circuit if it is analog engineer. I mean, in the VLSI itself, we have analog and digital domain. So if it is an analog domain, you should know at least digital analog also. Any questions here?
No, sir.
So I had discussed this I2C and VLSI, I2C and SPA in the basic embedded system. So if I consider I2C interface, what are the lines do we have here in the I2C interface? In the I2C interface, what are the, first of all, what do you mean by I2C interface? Why do we need I2C interface? Why do we need I2C interface? Is it a serial communication or parallel communication interface?
Serial communication.
Yes. So it's a communication interface, right? It's a serial communication interface. So we have SDA and SCL lines, data and clock, right? So what is the difference? What is SDA? What is SCL?
Serial data and serial clock.
Serial data and serial clock, right? So why do we need clock here in the SCL? First of all, why do we need this clock? So with respect to data, we'll be sending the clock also, right? Why do we need that? Why do we need clock? I can send just data, right? Why do we need clock? Good. It's a synchronous data bus. Synchronous in the sense, at the receiver end, with respect to every rising edge of the clock, we will sample the data. Every rising edge of the clock, we will sample the data. This is called synchronous communication. Because actually using clock, I can identify which is the start bit, stop bit, all these things. So usually in I2C communication, we will have one start bit. And we will have data. And we will have stop bit. Okay. So also, for instance, you assume one master is there. So like same SDA and SCL, I'll be connecting to all the line slaves, SDA and SCL, SDA, SCL, SDA, SCL. I'm connecting same. So how slave will get to know whatever the data I am transferring, it's for him only? How it will get to know? How it will come to know that, like, whatever the data I am transmitting, it's for this particular slave. So we have S1, S2, S3, you assume. So this is the master. So how he will come to know that, like, whatever the data I am transmitting, that is for him only? Master has to specify it. How he will specify? No, not according to availability of slave. There is something other thing actually. According to the data, we will send something. So that slave will get to know. Can someone tell me what is that? What we are sending? So we will be sending something called slave address. Slave address. So based on this, actually, like, these slaves will be selected. Okay. So slave address will mention. So each slave will be assigned with one slave address. Maybe if I say 70, 71, 72. So for instance, if master sends like start bit followed by slave address 71 and data, so it will reach all the slaves, but initially it will read what is the slave address, and based on that, actually, like, it will choose like which slave has to be identified. Okay. Next is actually SPI. So in SPI, do you remember what were the lines we have? In SPI, what are all the lines we have? Yes. We will have SDA, that is data. No, not SDA. We will have chip select. We have MOSI. We will have MISO. And we will have clock. Okay. Why it's coming here? So Miso and Mosi will be common. Okay, here Miso and Mosi for across the slave. And Mosi. Here also. But we have different clocks. Clock also same. Okay, sorry, clock also same. Clock also common. But we have different chip select for each slave. Different chip select for each slave. So with this configuration, like, can you tell me what is the so this discussion, whatever we have done with respect to I2C and SPA, with this discussion, can you tell me what is the disadvantage of I2C and what is the advantage of I2C? What is the advantage of SPA? What is the disadvantage of I2C and what is the disadvantage of SPA? Can you tell me with this discussion? Can you predict? One difference is I2C is half duplex. What do you mean by half duplex? Anyone? I2C is half duplex. SPA is full duplex. Can someone tell me what do you mean by half duplex? What is half duplex? Full duplex. Actually, like in embedded system class, I had given you one bridge example also, right? So for the half duplex and full duplex. So anyone remember that?
In half duplex, both parties will communicate but not simultaneously. In
Yes.
full duplex, both parties communicate simultaneously, like walkie-talkie. These are all examples.
Full duplex. It's like not walkie-talkie. Walkie-talkie is something like half duplex. So only one person at a time they can communicate, right? So full
Yes.
duplex is nothing but your mobile phone. Both parties can communicate simultaneously, right? So what is a FM radio? Is it a half duplex?
No,
What
sir.
FM radio is called? Half duplex? Can someone think about it?
No, sir. It is not neither half duplex nor.
Then what it is? Do you remember the name? This also I had told you in the embedded class. It's a simplex. So these are all they will ask in interviews, actually, in embedded system interviews. Okay, that's the simplex. Okay. Any other advantage here? Any other advantage? Which is faster, I2C or SPA? Which is faster? I2C or SPA? By looking, which one do you SPA, right? Because SPA has both transmission and reception faster, and like in the half duplex, it will be very slow, right? So SPA is faster. Okay. Which requires more line? SPA requires or I2C requires more line?
I2C.
I2C requires more line? Are you sure? Think. SPA requires more connection because I2C for each slave, I need not have different connection, but here we have more chip selects, right? But one more thing, for the longer distance, which is preferred? I2C or SPI? For the longer distance, which is preferred? I2C is preferred, or so for instance, if I want to communicate to the 10 meter, 20 meter, which is preferred? For the longer distance, I2C is preferred because we will be having external drive. Actually, like for the I2C, right? We usually give one. It's an open drain configuration. So this you should note down these points. Okay. So this they will definitely ask in the interviews. So that is open drain configuration. I was mentioning about this MOSFET based configuration, right? So it's an open drain configuration. So externally, so it is not driven by pin. So externally we will be having plus 5 volt, plus 30 volts, whatever you want to drive. But SPI directly driven by pins. So that's where actually like SPI is less distance compared to, but for longer distance always it is preferred with UR, okay, because we do not need to add extra clock with the data. So it's purely UART is a asynchronous communication. Asynchronous communication. Okay, asynchronous communication. Because of that, UART is preferred. Okay. So with the UART, we will have actually start, stop. Along with this, we will also have parity. What do you mean by parity actually? What do you mean by parity?
Odd or even number of 1 bits.
Yes, why do we need that? Why do we need parity?
To check total number of 1 bits.
To check total number of? No, not for checking it. It is not for checking. So for checking, I could have done some kind of counter logic itself, right? Why do we need parity separate? It is an extra burden actually for the, but still we use parity. Any reason?
To check the message, it is transmitted properly or with any errors, something like that.
Good. So it is actually to search the errors. Okay. So if I say, if I'm sending 0x88, so what is the parity bit? Do you remember? I had taught you also to calculate the parity, how to calculate the parity. Does anyone remember that? How to calculate the parity? Basically, we will XOR this, right? So what is 8 in binary?
100.
So we will XOR this. 1 XOR with 0, 1, 0, 1, 0, 1, 1, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. It's basically 0. Right? In this way, actually, we compute the parity. So it's actually like for the long distances, we have this error correction or error detection mechanism, right? So very long distance UART is preferred, and like you need not transmit the clock also. Whenever you transmit the clock, there is always possibility of emission, interference, all these things. So it is actually preferred. Okay. Okay, we will launch some polls. Okay. Then I have one last topic, that is like other than Arduino, how we can program. Directly, actually, we can program, and like we can use for the web interface like JavaScript. I mean, for the live updation of the data, and also we can use JavaScript, all these things. I'll just give you a very brief about that, but let's launch some polls, then we will discuss on that. So this is the first question. So this is like what we had discussed about assembly. So I just wanted to recall all the topics what we had studied so far in the embedded analysis. So since this is the last class today. So it's actually like continuously will be jump if no zero stat. So it will be while loop, right? So it's actually while one kind of condition. So it will be running continuously. So this is actually how many 8051 has how many 16-bit counters or timers. So basically it has two timers, right? So first of all, can someone tell me why do we need timers or counters? Why do we need timers? So in the embedded we had discussed, right? Why do we need timers or counters?
Provide delay.
Provide delay in microcontroller, right? So or like to monitor some timings. So for instance, like especially in the malls, you might have seen that like whenever you enter the house, right? Enter the mall. So what happens? Automatically door opens. After some times, maybe like 15 second, 20 second, you will just close that, right? So that kind of monitoring of time, or like in factories, and also you have to monitor how long it's taken and such things like counters, timers, you will be using that. Okay. So let me launch next question. So this is actually, there is nothing such as internal code, external code, all these things, right? We have data and code memory. So do we have internal data? External data is there actually. Yes, I mean that is actually like it's not divided into such memory, different memories. Okay. So next thing, last question actually. Yes, so external data can be pushed only through MoveX command. That's correct, right? So it's actually for the external memory. So MoveX is basically for the external memory. Okay. Fine. So for if it is the internal memory, which one do we use? Can someone tell me? So MoveX is for external memory. So if I want to transfer between the internal memory, which command do I use? Just move, right? Just move. Good. Other than that, I had few more like interview question. What usually they ask with respect to 8051. So one is RAM size. So one is timers. So other thing. So how generally that interrupt get executed? That is the most commonly asked question. So in 8051, how the interrupts get executed? Can someone tell me? So for instance, if some code is running, so suddenly external interrupt or internal interrupt gets internal interrupt gets executed. So what happens actually? How exactly the code flow will become? Yes. Have you heard about internal interrupt vector table? Hello students, are you there in the call?
Yes, sir.
Yeah. Have you heard about interrupt vector table? What is that?
Yes, sir.
What it does? So it will have where to actually, once the interrupt get executed, where your code has to redirect. So these are all the things you should know actually. So these are, you are all in third years, right? Third year. I mean, in next 3-4 months, your placement will start. So you should understand all these things. So how this interrupt vector table gets executed, what is the use of this use timers, counters, how that memory gets accessed, right? So 8051 is a 8-bit, 16-bit or 32-bit processor controller. Is it a 8-bit, 32-bit or 16-bit controller?
$16.
Yes, it's a 16-bit controller, right? Okay. So, we actually like before closing. So far actually like we have seen Node MCU based Node MCU with the Arduino, right? So just I want you to introduce how we can use the Python also for Node MCU. Okay, that will be actually like most of nowadays, like most of the data analysis, like if you are planning for artificial intelligence using Node MCU, most of the data analysis tools are available with the Python, right? So I will just give you a very brief introduction in the next 20 minutes, 25 minutes or so, how we can use MicroPython. I mean, like for the microcontroller, we have something called MicroPython. How we can use this Python for Node MCU. Okay. So far, actually, like we were using Arduino tool, right? Arduino. I mean, like through INO file we were fusing. Okay. So actually internally we were initially we were discussing that there is a TCP IP stack inbuilt to that ESP processor, right? So now actually like we have to reflash that ESP with the Python based firmware, MicroPython firmware. Okay, so first we need to connect that Node MCU with the MicroPython with our laptop. Okay, so then what we have to do is like we have to download Flasher. Okay, so I'll just give you the link from where we can download that Flasher. So there is actually like MicroPython is a separate language. It's slightly different than Python. So you know embedded C, right? So embedded C and C. So C program is basically for what application? It's just for general purpose application, but embedded C is optimized for embedded application, right? In the same way, MicroPython is actually optimized for embedded application. Okay, so first go to this link, whatever the link I have shared. So you will get firmware for fusing it for the Node MCU. Okay, so ESP8266. So download this. Okay, zip file. It takes maybe like in on my internet speed around 2-3 minutes. And parallelly, I'll give you another link. So please note down this link. Maybe like if you are like not able to do it, if you are using mobile, later point of time also you can try. So you also, whatever the download you do, you need to flash it, right? For that you need Flasher. So you have to download from this GitHub the Flasher. If I go to this link. So download entire thing actually. So you can download zip option will be there, right? So download entire thing. It's a small file, so it will be downloaded faster than this. So once you download, when you unzip it, so you will get two versions. So if you are, I mean, nowadays like most of you have Windows 64, go to Windows 64, release, you will get this Flasher. So we have seen COM3, right? So choose COM3. Okay, so here we have to choose that file. Let it download. So for looking into that, so actually for seeing what is there in the Node MCU, how it is operating, right? So we have to download CoolTerm. Okay, 3 software. Okay, this link also I'll share. So here we need, so for the MicroPython setup, we need 3 softwares. So let me download this as well. So don't click on this. Okay, so usually these links. So maybe I prefer UK link. This will be a bit faster usually. Yeah. So this flasher also got downloaded, right? So now go to this flasher. So choose this. So first you have to unzip that. What are the flasher you have downloaded? Not flasher, like the bin file. So this MicroPython. So this cool term also will let's install. This is application, so you have to launch. So go back here. So this is what we have downloaded, right? So if you go here, this is a MicroPython bin, what we have to flash. It's not downloaded properly. Let me just check it. So here itself, I should have, let me just check. Just give me a second. So actually, like you have to download the bin, okay, not MicroPython. So you see 8266.bin. So I'll just share you this link also. Previous links, did you all get it? I had shared 4 links. Did you all get those 4 links? Hello students, are you there? Are you following? Yeah. So download this link. This is a small bin file. So actually from the flasher, you have to choose that bin file, okay? Here you will not have browse option. Let's see, yeah, browse is there. So downloads. So this bin you have to choose. Yes. Right. Now go to config in the advanced. You have to choose the baud rate basically. Okay? or I mean by default you can go to the operation port and you can just make flash also, but automatically it will pull. So it's ready now. So you got this Mac ID also, right? So now you have to go to the full terminal, whatever we have installed. So connection, connect, or you can go to the options. So in the Node MCU, right? So for instance, like here, connection. So the baud rate is 115200. Okay? And rest of the things keep it as it is. Okay. So this rain detected, whatever we are seeing, right? That is from the previous serial monitor thing what we have used. Do you remember? This ADC value, rain detected, all these things, right? So same way you can just type, let me just stop this maybe. So you can just reset also because you fused the firmware, right? Looks like some issue. So you can see we had programmed that. Yeah, now what we'll do, it's getting programmed actually. Connect 3. Try flashing. So here also you try to make it 115200. Okay. So actually there is some, I mean, since we have programmed, if you remember, so this ADC thing, right? So that's the issue it's creating. So maybe like we'll do one thing. So we'll disconnect this. Don't save. Now you try connecting. Yeah, now it's getting programmed, right? So if you see here, it's getting programmed. Because we had opened that serial monitor that was creating the issue. So it got completed. Now what we'll do? Now you go to the full terminal. Okay. This will cancel. Launch this application. So here, connection, connect. See here, Node MCU build powered by Lua. So this is actually like previously you were seeing that ADC window, right? So now it's a Python window, you can see, right? So you can just see print. You can print. Just we will print hello world. See, so it actually, this is actually entire Python, right? You're running on the Node MCU. So this is, if you see here, we have connected to the Node MCU and there we are running. So in this way, we can run micro Python based codes also in the Node MCU. So I'll share you some reference textbooks also in the Google Classroom link. So you can download that and like try some of the programs in that also. Okay. So that's all from my end. Let me know if you have any questions, or else we will end the session. Thank you all for attending my all 4 sessions, and all the best for your future endeavors. So if you have any questions, you can ask, or else like I'll give you 2 minutes, else we will end the session. Thank you then. Thank you all. So if in future also, if you have any questions, directly in the classroom link, you can mail me or post something so that I can answer. Okay. So related to interview questions or anything. So if you have any doubts, you can queries, you can ask. Okay. Thank you.